We're not going to be solving anything today. So that's good. We're just going to be looking at equations and things about them as far as properties and if things are true or false, hence the name true and false. If you were curious on the bell work questions, I looked at, most people did okay on the first one. The first one, the answers were 11, math is hard, -6, 8 and 4, no, 42, 30, I can't remember, 30, yeah, 30, sorry, it wasn't loading. And then Wally, he did not distribute correctly, which a lot of people got. In the first step, he did not distribute the 2 to the -3, which would have ended up being -6, and he left it as -3. So that was the problem on the second bell work question. I do want you to have a calculator though, so if you haven't gotten one, please get one or have one at your desk, because we're going to be like adding a lot of like fractions and decimals and stuff, and not saying you can't do it by hand, but I want us to be like move a little bit quickly through that. So first thing, we have a statement, 4 + 5 = 2 + 7. Is that true or false? Okay, how do you know? Okay, because 4 + 5 is equal to 9 and 2 + 7 is also equal to 9. I agree. The second statement says 1 + 3 = 8 + 6. Is that true or false? False. And we know that because 1 + 3 = 4 and 8 + 6 is 14, and those are not the same number, okay? So these are called number sentences. Just like in English language arts, when you have like sentences, we also have sentences with numbers too. So a number sentence is when we have a statement that has an equal sign between two numerical expressions. So on both sides of the equal sign, obviously we involve some sort of numbers. A number sentence is true if both sides are equal. If both sides do not equal the same thing, then we are going to call that false. So if they both equal a different number, then we're going to say that that is false. So all we're going to do is we're going to look at equations and decide, are both sides the same or are both sides different? So if we look at letter, and here, I'll leave that up there for just a second because I see some of you still working on that. Okay, so if we look at number 1, 13 + 4 = 7 + 11. True or false? Okay, we're saying false. And I do ask you to justify your answer. Now, that doesn't necessarily need to be words. You can just tell me what each side equals. So the left side, 13 + 4 is 17, 7 + 11, 18. And you crossing that equal sign obviously is telling me that those do not equal each other. 17 does not equal 18, obviously. Okay, letter B, 1/2 + 5/8. You could do that by hand, but remember I showed you the fraction button on this calculator. So if I did 1/2 + 5/8, you should get something that looks a little weird, right? But that is saying 1 and 1/8. And then we have 1.4 minus 0.275, which is 1.125. So they're not in the same form. I have a fraction and I have a decimal. So how could I find out if those are the same or not the same? What could I do? Yeah, I would suggest turning the fraction into a decimal. So we want to take 1 and divide it by 8. Which equals 0.125, but I have that whole number still. And it does look like they equal the same thing. So we're going to say that that is true. All so I want you to do the next two under the try it. So you have A and B, and let me know when you're done because I want to come look at your two answers. Digital student, same thing. Send me your answers to the try it once you've done them. Again, it's fine saying true and false, but I also want you to tell me some way that you know that, either telling me what they equal or if there's a property you can identify. I don't care. But make sure you tell me if they are true or false and why. All right, so most people I looked at did well on this. I actually was really happy with some of you that on letter A, you could have figured out that they both sides equaled, what was it, like 21 million something thousand, I don't know. But regardless, you could have also noticed that there were two properties that happened to change the first one to the second one. And those were the associative property, which some people said, and the commutative property. So the parentheses changed place and the number switched order. So you could have told me that, or you could have told me that they both equal the 21 million, whatever thousand, 255, I can't remember. Letter B is false. And the reason why is the left side, if we were to simplify that, it would be 6 plus 4, which is 10. 10 squared is 100. And then the second one, 6 squared is 36, plus 4 squared is 16. And if we add those, it's 52. And those do not equal each other. So I would say that that one is false. Okay, cool. All right, so we're going to start talking a lot about equations. And so equations are just when we have two expressions that are equal to each other. Good job, Gabe. That's right. Algebraic equations can be number sentences. So we can just have numbers, but most likely in this class, we're going to be looking at things that also have variables. So some sort of unknown letter that we're trying to look to see what its value is. So we're going to do some deep thinking. We have 4 times x plus 2 equals 4x plus 8. Are both sides of that equal sign equivalent to each other? Are both sides saying the same thing, I guess is a better way to phrase my question. 4 times x plus 2 and 4x plus 8. Are those the same thing? Mm-hmm. How do you know?
4 times x is 4x. 4 times 2 is 8.
Okay, so yes, they are. What do you know what property that is if we take that 4 and multiply it by the x and the 2? Yeah, so yes, because of the distributive property. We could make both sides equal the exact same thing. So we could distribute that 4 on the left-hand side to make it say 4x plus 8, which is exactly what the right-hand side of that equal sign says. Okay, now I'm going to give you like 30 seconds. I don't want anybody to say anything. I just want you to think about this. Can you think of a number that we can put in for x to make both sides equal to each other? And if you think of one, I want you to write it down. Can you think of a number that we can substitute in for x on both sides of that equal sign to make the same thing on both sides? So just think about that for like 30 seconds. And if you think of something, write it down. Did anybody come up with a number? Ryan? 2. Did anybody come up with a different number? Yeah.
1x.
1. I'm going to say 1. Lucy?
12.
12. Did anybody come up with anything else? Does anybody have an idea of what numbers would go in here and make this true? Besides 2, 1, and 12? Any number. Yeah, Holly, you're right. Anything. Any single number that we substitute in is going to give me the exact same thing on the left as on the right because both sides say the same thing. So we could literally substitute any number, any whole number, zero, integer, fraction, decimal, it doesn't matter. If we end up with the exact same thing on the same side, on opposite sides of the equal sign, we can substitute any number we want to and make that a true statement. So like if I pick any number, so 10, on the left hand side, 10 plus 2 would be 12. 12 times 4 is 48. On the right hand side, 4 times 10 is 40. 40 plus 8 is still 48. So you could use any number that you wanted to. What about the next one? The next one says x plus 3 equals 9. What number makes that true? 6. Specifically x equals 6. Can you think of any other number that would make that true? Would any other number, if we add 3 to it, give us 9 besides 6? No. Yeah, so there's only one number, one value that we can use to make that true, and that value is 6. Okay, last one we're going to look at. X plus 6 equals x plus 9. What number would make that true? And keep in mind that those x's have to be the same thing because they're the same variable. So what number could we add 6 to equal the same thing that we're going to add 9 to? No guess is a bad one.
-3.
-3. Okay, so let's try it. -3 plus 6 is 3. -3 plus 9 is 6. Not -3, unfortunately. Connor, what were you going to say?
You can't add them.
Yeah, you can't. There's nothing.
Oh.
Yeah, there's nothing. You can't take the same number and add 2 different things to it and get the same number, right? There's not, it's impossible. We're going to end up calling this eventually no solution. You may have heard that before, maybe not. But for now, we're just going to say no number. There's no number that we're starting with that we do 2 different things to that we get the same number. It's impossible. All right, so let's do the try it. I do want to do this together. So d squared equals 4. So what number, when we square it, do we get 4? 2 and there's another number besides 2. Gavin, you got it. Think about that. -2 squared means -2 times -2, which would still give us +4 as the result. Letter B, let's combine our like terms on the right-hand side. So we have 2m, and on the right-hand side, m plus m would also be 2m. So I have the exact same thing on both sides of that equal sign. So that is going to be true for any number. It does not matter. Fractions, decimals, integers, 0. I'm going to get the exact same answer on both sides. All right, in letter C, I have a value D, and I'm adding 67 on one side. I'm adding 68 on the other. What numbers is that true for? Yeah, none, no numbers. That is not going to work for anything. I'm not going to get the same value ever if I add 2 different numbers to it. And same if I subtract 2 different numbers. I'm not going to get the same answer. Good. Okay, let's look at the beat the test, and then we're going to move on to like the second part of what I want to do today. So it's giving me an equation and an answer, and I just need to decide, is that answer right or wrong? So what I would do is I would substitute that answer into the equation and see if it's true. So they're telling me that the answer is 7. So if I plug in 7, 2 times 7 is 14. Yeah. True. Yeah, I agree. So 14 plus 5 does equal 19, which would be true. The second one, they're telling me that the answer to x is 3. So let's substitute in 3. So 3 plus 3 is 6, plus 2 is 8. 8 minus 3 is 5. 5 does not equal 16. So I'm going to say that that is incorrect. The third one, we want to substitute an 8 where x is. So 8 plus 2 is 10. 10 divided by 5 is 2. That's true. 2 times 7 is 14. 14 minus 8 is 6. True. And then the last one, 1/3 x. So 1/3 of 18 is 6. 6 plus 5 is not 14. So the last one would be false. So the first, the third, and the fourth would all be true.